one key requirement for trustworthy AI is transparency. In particular, we want to have transparency in federated learning systems. And one way to define explainability is via the following idea. So you say a machine learning method is explainable to a user. So this is important here. Explainability always refers to a specific user. That's why I call it subjective explainability. The same federated learning system might be explainable to one user, but not explainable to another user. And so when is a model or a trained model explainable to a user? And I say, or my approach to this is, it's explainable if the user can guess the predictions. So if the user can already anticipate what the prediction would be. So I measure this difference between the prediction itself. So this is the prediction delivered by a linear model with model parameters Wi. And this I call user signal. It's basically the guess. So I show the user the features of a data point, and the user should tell me what would this model predict. And if the user can accurately guess what the prediction of the linear model would be, then I say it's explainable. So explainability means that the user knows already how the model will behave or predict a given data point with features X. That's my take on explainability. And there are other definitions of explainability, but that's my take and also of some other researchers. So do you have any comments or questions to this approach? Would you define it differently? How would you quantify or measure explainability of a trained machine learning model? I mean, this is somewhat related to doing an exam, like showing the user data points with features and asking the user to tell how would this linear model, this trained linear model, predict the labels for these data points. This is like an exam. So this is similar to what I do when I want to test your understanding of the course concepts. I show you also examples. So the test set in your case would be the quiz questions in the My Courses quizzes. And then I compare your answers, your guesses, with the model or reference solutions. So that's how I test if you understand kind of some intrinsic model behind the federated learning theory. So it's somewhat similar in spirit to test the understanding of a machine learning method by letting the user predict its predictions. So this user signal here, this is the prediction or the guess of the user of the prediction that should be or will be delivered by the machine learning model. So it's not required that the user can predict the label. We do not require the user to make a good prediction of the label itself. It's only the question, can the user anticipate or guess the prediction of the model? And the model might be bad, might be a very poor model, but the user might understand it well. It has nothing to do with the prediction accuracy. So we do not compare against the true label of the data point. We only compare against the prediction of a machine learning model that I want to explain to a user. Okay, so if you subscribe, if you believe me that this is a useful measure for explainability, then why not taking it as a regularization term? So if we say this measures the explainability, and if the explainability is high, so the user can predict well the labels or the predictions of the model, so this should be small, then let's use this as a penalty term. So we add this explainability term as a penalty term to the local training error. Yes? Yes?
The user prediction is called
yes.
So you as an example, right?
Good. Yeah, very good. So how can this ever work? You show the user a bunch. So let's say this weight vector or this parameter vector is the parameters of a object detector. An object detector that reads in the pixels of an image. These pixels are the features X, and you want to understand, or you want to measure how well does the user understand this object detection algorithm. So you decide a test set, this DT test set, a bunch of images, test images, and you let the user. So you tell the user in the experiment, what's your guess? Will this model detect if there is a cat in the image? Yes or no? So and these predictions are this user signal, and then you see how much do this user signal or this user guesses agree with the prediction of the model itself. Cat, yes or no?
The user not sure what's
Yes, yes. The user might have a limited understanding, yes. But the user might have a high understanding because the user might be a machine learning expert who knows the model used by this cat detector algorithm, knows about transformer networks, knows about the training set that has been used by this method. So some users might have a pretty good idea that for these test images, the model might hook on this edge and say, okay, this is a cat. But this, of course, depends on the user. So for a random, let's say for a school child, 10 years old, it might there might be a very big deviation here. So there might be this might be a large value. But for a machine learning or computer vision expert, a postdoc in computer vision, this might be very small. Well, this is just a proposal for how to measure the understanding of the user that provides us this guesses of the machine learning model. It's just one way to measure it. I mean, how would you test otherwise if a user understands this cat detector algorithm? You could ask the user, write me an expose or write me an yes. I make no assumptions about the background knowledge of the user. This is what I want to get out of this quantity. So I don't know anything about the user beside the guesses that he or she gives for these test set images. I just Yeah, that's a good question. So how you design this experiment that delivers these numbers might actually influence the knowledge of the user somehow. If you tell the user more about the machine learning method that they should try to anticipate. Yeah.
Maybe it's not a cut. Maybe it's like project.
Yeah.
So they like see these pixels. Can they be biased? Like they have their own like mental algorithm going on?
Maybe, yeah. Yeah, maybe. But these are the details I try to abstract from. From me, the only thing that I see about the user or that I use to profile the user is this quantity. But yeah, of course, it depends also how you design the experiment to get these guesses. And this should be documented as a form of accountability. Yes. Yeah.
Saying what was the decisive factors in the decision. And then this kind of explanation would basically go and measure whether this explanation is successful.
Yeah, so these counterfactuals, but in the end, they're also a way to somehow tell the user or inform the user about how this mapping from features to label is. So it's again one way to tell the user or to explain the user the function edge. So this hypothesis, what's this function? And so this tests basically if the user can replicate the function values of this hypothesis for specific data points for which we know the features. Yeah, so maybe I let it sink in for a while. And yeah, I would be happy to hear more comments than on Slack or by email, because this is really current research in my group, and would be happy to also start a collaboration if this is also along some of your research interests. Yeah, then so let's assume this is a good measure for explainability or lack of explainability actually. So if we want to minimize the lack of explainability, we should penalize it by adding it as a regularization term. And if we again use linear models, it turns out that this whole expression here turns out to be a quadratic form, a convex quadratic function in W, which is parameterized not only by the labels and features now, but also by the user signals. So computationally, we end up again with minimizing a convex quadratic function. And all the analysis of gradient methods for convex quadratic functions also applies here for subjective explainable federated learning. Okay, that's it for today. You find now the overview of the coding assignment in the end of this lecture, of this section in the lecture notes. And yeah, please remember the deadline is not on Sunday, but on Sunday in a week. So you now have a bit more time for this quizzes. Yeah, thanks for your attention. Are there any questions at this point? Yes.
I was like wondering what the user requires that user explain or that like you're not someone can provide the explanation, like in the linear regression.
Yeah.
Say that okay, these are the way.
Yeah.
But like, if someone can do that, isn't it enough? Okay, maybe there's some use case where you want the users to know, like.
Yes. Yes. So very good point. So again, this explainability is subjective. So we might not need at all this penalization because the federated learning engineer or the system designer knows or has a very good understanding of what the model will learn. But the key thing is that the user can be a 10-year-old kid, should also have some understanding, or we should also ensure some explainability. And this is what this key requirement also touches upon. We must ensure explainability for all kinds of different stakeholders. And the stakeholder can be the random user, teenager of a TikTok app, or can be a professor in machine learning. Then, of course, you have different levels of explainability, but this is a way to ensure explainability in an automated fashion. I mean, the premium solution would be to invite this teenager who uses TikTok to a one-day seminar with me where I explain all the details of machine learning to him or her. And then he has a better understanding. But this is very costly. I mean, of course, for me, it would be beneficial monetarily if somebody pays for it. But this is something that can be completely automated. And to some extent, I might make myself also redundant, because you can then optimize the predictions. Like, let's say the predictions could be, what's the best design of a lecture that I give today in order to optimize your understanding of federated learning. And this understanding is measured by the error on a test set, like a real test, an exam. So this would be kind of the let's say the long-term future solution for education, for automated education. Okay, any other comments or critique about this approach to explainability? Yes.
Could be like an average or something to have like some statistics on the whole concept to give you a good picture of the course design.
Yeah.
But how would you like? What do you think about that in practice? Because this is like one user.
Yeah, we would learn. So one user is this superscript I. We have a separate model for each user. So we train a separate teacher for each one of you. So basically, I would be cloned and optimize my teaching to your background. So if some of you have a background on spectrograph theory, my clone would do more details on the spectral, on the analysis of this federated learning algorithms. If others of you have less, another clone would optimally bring you up to speed in basic linear algebra. So these models here, these are, so to say, personalized models. And we measure the subjective explainability for each user. So there's a different subjective explainability level for each user I. Yeah, I mean, I have also thought about this because it's challenging to implement this in an experiment. So what could be a user study? And one user study, or it's very related to this personalized learning apps. So kids nowadays have these learning apps like Duolingo, I know, coincidentally. So, I mean, that's the same goal or the same problem setting as an explainable machine learning. You want to guide the user, or you want to train a model such that the user optimally understands it, understands something. In education, you want the user or the school kid to understand linear algebra. So you make predictions about what to show the student, which examples to give him, such that, or her, such that in the next exam, he or she will optimally predict the answers, the correct answers. So in an exam, these predictions would be the predictions for the correct answer, so to say. And the user, in this case, the student, provides his or her guesses for the correct answer. Okay. Yes. I think this is pretty much open. So there's also, as I said, there's no consensus about how to measure explainability. I don't know any document by the European Union where they define a measure for how to measure explainability or how to measure transparency. I mean, there are measures for communication, like bit rates. How many bits can you communicate over this channel? Or there are measures for the weight. How many grams does it have? So for certain quantities, we have well-defined procedures to measure it, but explainability, I didn't see yet an official regulation that tells you have to measure explainability like this. So, but let's see, maybe I'll try to lobby a bit in Brussels. Yes.